Okay children, now let's have a look into the chemical properties of metals. Okay, the first property of metal that we are going to learn is reaction with oxygen. Metal will react with oxygen to give metal oxide. Okay, metals will react with oxygen to give metal oxide. We already know that magnesium metal will react with oxygen to give magnesium oxide. Mg plus O2 gives MgO. Likewise, sodium metal will react with oxygen to give sodium oxide. Now the important thing that we have to know here is that metal oxides are basic in nature. Metal oxides are basic in nature. How do you know that metal oxides are basic in nature? We already know a test to find out whether the solution is basic or acidic. So the metal oxide, if you mix with water, we are going to get a basic solution. For example, MgO with water will give metal hydroxide MgOH twice. Calcium oxide with water will give calcium hydroxide. Metal hydroxides are bases. So, if you dip a red litmus paper in this solution, it will turn blue. So, metal oxides are basic in nature. Another way to find out whether metal oxides are acidic or basic, that is neutralization reaction. Metal oxide upon reaction with acid will give salt and water. Metal oxide on reaction with acid will give salt and water. Already we have learned this reaction as a neutralization reaction. How it is a neutralization? Because metal oxides are bases. Acid plus base will give salt and water. For example, magnesium oxide plus HCl will give magnesium chloride and water. MgO plus HCl will give MgCl2 plus water. Hence, we can say that metal oxides are basic in nature. But are all metal oxides bases? No. There are some metal oxides that we can call as amphoteric oxides. Amphoteric oxides are those oxides which will show both acidic and basic character. Two such examples are zinc oxide and aluminium oxide. Both zinc oxide and aluminium oxide can react both with acid and base to give salt and water. For example, Al2O3 plus HCl will give AlCl3 plus H2O. Al2O3 plus NaOH will give NaAlO2 plus H2O. So here we can see that aluminium oxide is first reacting with an acid. It is giving the salt, aluminium chloride and water. At the same time, aluminium oxide can also react with the base sodium hydroxide and give sodium aluminate, salt and water. So, they are amphoteric oxides. How can we prove that zinc oxide is amphoteric in nature? The same type of reaction of zinc oxide with acid and base to give salt can be identified. Okay. Now, when we talk about the reaction of metal with oxygen, we can also say that non-metals also react in a similar manner with oxygen to give oxide. Okay, for example, sulfur. Sulfur is a non-metal. Sulfur will react with oxygen to give sulfur dioxide SO2. S plus O2 gives SO2. Sulfur dioxide. What will be the reaction of sulfur dioxide with water? Unlike metal oxide, non-metal oxide on reaction with water is giving an acid. SO2 plus H2O will give H2SO3. Hence, we can say that non-metal oxides are acidic in nature. Okay. In a similar manner, carbon dioxide, which is a non-metal oxide, will react with water and give the acid carbonic acid H2CO3. So, when we compare the property of metal oxide and non-metal oxide, what we can say? Metal oxides are basic in nature, non-metal oxides are acidic in nature. The second reaction of metals that we are going to learn is metal with water. Okay, metal reacting with water will give metal hydroxide or metal oxide in some cases plus hydrogen. Okay, metal plus water will give metal hydroxide or metal oxide with the release of hydrogen gas. Okay, So here we can see that the highly reactive metals like sodium, potassium, lithium, etc. will undergo a vigorous reaction with water. Na plus H2O will give NaOH plus H2. How it is such a vigorous reaction? We can say that the hydrogen released in this process, in this reaction, will catch fire immediately. Okay, it will release large amount of heat so that the hydrogen produced will be catching fire immediately. The same thing we can observe when we put a small piece of sodium in water. Okay, but this is not the case for moderately reactive metals like magnesium and calcium. The reaction of such metals are not much vigorous and hydrogen released will not catch fire easily. And also we can say that these moderately reactive metals does not react with cold water. They need little more higher temperature, so they react with hot water to produce metal hydroxide and hydrogen. Okay, for example, Mg plus H2O gives MgOH twice plus hydrogen. And here we can note that it can also float due to bubbles of hydrogen gas sticking to its surface. Okay, this is one important observation. Now, the less reactive metals like iron, aluminium, zinc, etc. will react only with steam. They can neither react with cold water nor with hot water. They need very high temperature. That means water should be in the form of steam. And here we can say that these metals, upon reaction with steam, they are producing oxide of the corresponding metal and hydrogen. For example, aluminium with steam will produce aluminium oxide and hydrogen. Zinc with steam will produce zinc oxide and hydrogen. So here we can summarize that reaction of metal with water, metals like sodium, potassium, calcium, which are reactive metals, will react with cold water. Metals like magnesium and calcium will react with hot water. Then metals like aluminium, iron, zinc will react with steam. And there are some other metals like copper, silver, gold, etc. which will show no reaction with water. They are the least reactive metals. And also we have seen the observation calcium and magnesium will float as bubbles